Okay, let's get started with the security panel. Hey, I'm Sarang. I used to lead engineering for Sushi Swap, and I'll let you guys introduce yourself.
Hi, can you hear me okay? Right. My name is Anish. I'm a co-founder, CTO, and chief scientist for Panther Protocol, Privacy for DeFi.
Hey everyone, my name is Omar. I am CEO and co-founder of Security, a security audit firm.
Awesome. So let's get right into the questions. We've seen like an enormous of hacks happening recently, and like people auditing their code and then making like a small chain, and then still not re-auditing but reusing that audit reports of 8 times audited but still getting hacked after the post audit. So how do you think, as working in security and like audit firms, people should approach the post audit? Should it be a way where it completely gets invalidated, all the assumptions, and what are your thoughts around it?
I can give you a cynical one first. So most recently I had my circuits audited, and I had a very interesting challenge with the audit company. So essentially, the challenge typically you have is like it's an intersecting set of sets. What I mean by that is like if you have a ZK protocol would imply not just ZK, there's an underlying elliptic curve shit, and there's a cryptognomic mechanism design bit. So you have to find this set of people in the intersection of all three who are really capable of understanding this. And there are like probably 10 people in the world. And it's really, really hard for anybody to actually get this 1 in 10 people. And the thing is, the prices they ask for or the charges they have, I'm sorry if anybody's in audit and they do ZK, and we had this conversation and you said a big number to me, and I said, no, I'm so sorry, that's a reality, we can't afford to. Like, we need to have a mechanism to do this. The real challenge is like when the audit is done, you kind of get a timestamp that give you that. But there is no mechanism where it's globally transparent to everybody that this audit was done at this state by so-and-so. And it's a double-sided problem. One side of the problem is like if you do an audit and if the protocol has a problem, your reputation goes down the drain, okay? So they are very, very hesitant to give you, even if you prove to them cryptographically, say for example, you never say to anybody, you are going to have a protocol that's IND CCA1 secure, right? A lot of the protocols are not. Look at SSL, it's not. You don't have a security requirement, but you will have security auditors, I don't know why, they will say, I want this, okay? Now it's a question of like my belief versus your belief, okay? And then after that, they really wouldn't say to you, you know what, you fix this is what it is, and this version of your submission on GitHub, which is or GitLab or wherever that is, right? It's just a hash function of whatever that is. It's valid for this thing, these are the models. So I think the real challenge is, number one, we don't have a standardized set of threat models, which is very standard. If you go to build anything right now, you can go to Microsoft, you can download the threat modeling tool, it'll actually give you all the tools. You can actually have like, what is it that's there kind of thing. We don't have that. And we don't have, like when you actually get an audit, they don't provide you with a list of things that's, okay, they say this is a high risk, low risk, medium risk. But beyond that, they don't tell you like exactly what the risk translates to. And if I were a protocol builder, I get a audit. What I want to do is I want to publish, right? As in like I want to put it on the mainnet, right? Now, if any changes happen, then going back, again, I'll go back to the problem. The problem is like, even if it's like 10 lines of code, the audit company has to go through the whole problem. And this makes it very, very difficult for both the protocol and for the auditors. And being able to, link the two things, which is like this security model at the first audit and the security model at the second audit and the delta. And if you had the ability to just do that, that'd be amazing. That's what I would say.
Interesting. It's interesting that I think in the last 3 weeks we got 2 requests from the customers who want to create a registry of their bytecode, and they added us as signers, so they will have a few signatories who will sign all the bytecode. So there are auditors, there are developers, everyone signs that this is the code that was developed and audited. So I think there is, I see a trend, like two requests in a couple of weeks. So maybe the industry is moving in that direction. Also, I'd like to mention that apart from the post-audit changes, I'd like to emphasize that there are mid-audit changes which are extremely annoying to the auditors, and I think that we have to find a balance between trying to negotiate more costs from the customers and being loyal to them. Like when a customer comes with in the middle of the audit and tells us that they updated the code, technically this is a new code and this is new iteration of the audit, and this new code wasn't audited the full time. So of course sometimes you can accept that, like you look at this and you understand, okay, this is an isolated change and we can just let it slip. But sometimes it's really annoying and we either take the risk and take the costs and allocate more time to audit this, or we have to negotiate more costs. So it's not just post-audit changes.
Yeah, that completely makes sense. What are your thoughts around EOF, which is gonna get added in the Vector update and it's gonna come out? I mean, if you want no recording for this, so that you don't get grilled on Twitter, we can just cut that part out. But if you want to give your honest opinion, what do you guys think about EOF, and how does it impact the security landscape in general? Do you think it's good, or do you think we should not do it and wait for some more time, work on some other things?
Honestly, I don't have an honest opinion. I'm not even sure if it was accepted into...
Yeah, I mean, it's still going on, right? The discussion around it.
It's not yet accepted. Well, the core idea of isolation between the code and the data, like philosophically, it's kind of interesting in terms of security, but I don't have an honest opinion.
So I will talk from a very security perspective. So I've been doing security and cryptography for the last 25 years, give or take. So for me, I've gone through all the cycles. Sat on the ISO committee, wrote test vectors, wrote crypto libraries, and this is just an extension. So every other part of the normal world, execution and data are two separate things. If you look at your CPU, you will have buffer overflows if you allow that to happen, right? So as a general security principle, it's an interesting construct, but nothing comes for free. In the world of security, it's just about trade-offs. Are you willing to take this pain to get this gain? So there you go.
Makes sense. I think you guys went for a diplomatic answer, something that I wanted to avoid. But anyway, let's move on. We have recently seen a lot of Web 2 hacks happening more than Web 3, I feel, at least at the start of this year with like Bybit, and last year Radiant, and in fact the most recent one was ZK Sync. They keep compromising and their airdrop contract, whatever, right? And like if you look at in Web 2, there are like standards whenever a lot of money is handled, right? They're like ISO standards built for it. We certainly don't have that in crypto, and even if we have certain sub things, people don't follow, and even definitely the bigger companies. Otherwise, we wouldn't have those hacks, right? So how do you guys think we should improve it? And should the traditional smart contract auditing or ZK auditing companies should start expanding their, offering to even get the Web 2 infra side right? Because most of the auditors are from Web 2 first, right?
So again, I will say certain things. So full disclosure, I've done this bits, like I was personally involved in writing the test vectors for CVC mode for AES. So for me, I've gone through the real pain of writing arbitration number theoretic libraries, cryptographic libraries, standards, test, and move to this thing, right? So there are lots of good learning. What I mean by this is like right now, I can't think of a standard which you get, okay, this is the primitive, this is the curve, this is the test vector. You do this, you do any implementation, you put this thing in, you get that thing, your implementation is correct. I don't think that exists, right? I think there is value in doing that. And, I am kind of hesitant to give broad strokes, but I've pretty much said a lot of things a very long while ago. There was a piece that was written co-authored by me in 2019 or something, where I described this, okay? There are lessons learned. Every time there's a lesson learned, there's somebody who had the pain, right? If you look at the financial industry, they have a lot of the standards, right? The reason they have all the standards is like they have lost a lot of money. We don't have to lose all the money to learn these lessons. Those lessons for us are free. So, all the people in fintech, if you are a bank, there's a bunch of standards that's available to you. Mostly you can consider them as Web 2, and you can inherit that to a larger degree. There are some challenges, because it's very centralized. You have if you're in the UK, FCA provides you with a bunch of things. They say these are the cryptographic primitives you are allowed to use, these are the test vectors, these are the endpoints, these are the certificates for this thing. We don't have any of these things. So we have some challenges in mapping one-to-one, but whatever we can adopt, I think is free. The upside is free. You've already paid somewhere else through your experience or going through the pain.
Yeah, I think the fact that we have these Web2 hacks happening is very good. I think it signals that we are doing good as an industry, and it became hard to hack the smart contracts so that they fell back to the Web2 hacks. And obviously the next step is maturing the Web2 infrastructure of the Web3 companies. And yes, answering the question, I think all those who can should add this to their offering. If you have Web2 background, you have to offer the OPSEC and custodial security services as well.
Yeah.
So I just wanted to add this because it's very relevant in that sense. This is not the first time that we have big challenges in OPSEC. So if you go to any bank, a bank would definitely have an OPSEC policy, a very clear policy. And for some reason in Web3, I haven't seen such a thing. So to me, even if there's an offering, there's no downside for not following anything. So I don't know how we could fix that.
And just to add a little bit, I feel like the methods that we use to manage the orgs are a bit weird. We use either Telegram and Discord, which I don't think so are built for this, right? And we kind of push people towards that. And big companies, big orgs actually do not follow the, I feel like basic security standards, right? They might be very good at ZK, but they are very bad at managing basic level of security. So that actually segues me to my next question, right? The state of monitoring in crypto is still not as good, right? We have seen a lot of hacks that could be avoided if the company just had basic, maybe invariant monitoring, right? And especially now with having sequences in most cases being centralized. Do you think most of the transactions and hacks could be avoided if you just do an invariant check, and if the application's invariant break, you can probably not let that transaction included anyway. In Ethereum, that's definitely not possible at this stage. But maybe let's say Arbitrum Optimism, where it's still centralized in a lot of aspects, right? What do you think is around it?
I would say the politically incorrect thing. It's very much antithetical to Web3 to do check and execute. Okay, so the basic premise for Web3 is execute, right? Check and execute is something that you see in Web2 and all the financial institutions. But there's a huge value in doing check and execute. And the thing I would say is in Web3, it's like blockchain as I would describe it. If you have an LLM or a machine learning model, you have so much of data that it is very easy for you to train it. You have all the past states, all the vulnerabilities that's been published on chain, all the data that's happening is available to you live. So effectively, you could actually train a machine learning model and actually look at something. If it's like a graph, okay, let's think about the normal internet, right? At the back end of most of the internet, there are IDSs and IPS, intrusion detection system and intrusion prevention systems that's working really fast. They are looking at the transaction graphs across the globe and make decisions and allow you to go through, right? It is very possible to adapt the same technology to do what we are doing in Web3. Very easy to. But philosophically speaking, I consider myself more a purist, so I am hesitant to suggest that, but there is value to be had. If a particular chain, an L2 or a L1 wants to do it, technology absolutely exists.
Do you have any thoughts around it?
Well, I think the main thing about the monitoring is that huge number of startups started 3 years ago, and right now most of them have closed. Like,
Just to add, they were all shit, to be honest.
disappeared because I don't know why, but it's very hard to convince projects to integrate the monitoring solution. I don't know why.
Okay. So I'll explain the economic incentive problem here, right? So this is why I said what I said. When you have imagine you run a bank, okay? I know this is rhetorical, but in general, you are responsible to give the money that you put into the bank. You, as the governor of the bank, chairman of the bank. In a Web3 protocol, there is no such thing as your protocol got hacked, so what, right? So the incentive for a protocol to actually engage and to pay a fee on top of the sequencing fee, or transaction fee, just providing so-called what I call a security premium. That's how I would describe it. So this is the equivalent. You can do it two ways, right? You could just implement this as an insurance mechanism, an open market. You could have an easy double-sided market, right? So the set of all people who actually have these machine learning models, who actually put risk on each of the things happening, and there could be a set of people bidding against that. And what could actually happen is whenever something fails, you know the price of it and you can pay it out, right? So it's very possible to do, but unfortunately, because nobody has any incentive or responsibility to actually make sure that protocol really works, I think there's no incentive for anybody to pay anybody to monitor this or pay the insurance.
I mean, technically centralized L2s, right? They do have incentive, right? Because if a protocol built on their chain gets hacked, right, they lose TVL, they lose the volume, right? So and they can protect at the whole chain level, right? So I think they have a lot of incentives. They make a lot of money as well. I mean, some do make a lot of money as well.
Maybe they don't believe that these solutions work. I don't know. It seems so. They look at this, they say cool, but then maybe they think about false positives. What if they start censoring the transactions all the time? Well, it just means that you have to configure it properly.
Okay, so full disclosure. So I was involved 25 years ago creating test vectors for intrusion detection system, open source test vectors. So there's a massive learning curve, right? So I was involved in building a hidden Markov model. I don't know if you know Markov model, so I built a hidden Markov model. So what you have to, so there's a project in MIT, they created a test bench. I was a bunch of people involved in creating all these things, so you could actually have better security, right? If you go back in time and look at the attacks that were available on the internet, all the stupid open-ended attacks on IP stack, right? Really stupid ones. Now none of them work. Why? Because there is economic incentive for the people who operate the layers, every part of the layer, to prevent that. So if you are a cloud service provider and you are doing cloud scaling, if you have a hack on the IP layer, you're going to lose your bandwidth. So you have an economic incentive to deploy money to prevent that from happening. So, if you're Cisco, you really have incentive to make sure that your switches support the protocol that provides security. If this were the same situation in Web3, I'm just saying this, right? If there's an incentive, I'm pretty sure we will go through this growing pain. I completely agree with you about the false positives. We live a life of false positives, right? If you walk up to a doctor, you have a flu, that symptom could be mapped to anything from leukemia to everything else, right? Okay? Your doctor is going to say it's just a virus, it's a viral fever, because that's the most likely scenario. So, humans are pretty good at managing false positives.
Awesome. So my next question is towards, now we've seen a different trend in kind of getting your contracts audited, right? One is your manual audit with the firm. The other is the competitions now, which have been very popular. And what do you think is the exact recipe towards which way you should go for? Should it be just one or the other, or should it be a combination? And if it's a combination, what should be the sequence of the combination?
Yeah, I feel like both worlds are merging in some way, because all the contest platforms are are getting either acquired by audit firms or starting to offer audits, classical audits. And I see the audit firms, including ours, doing the contests. We do contests internally between our auditors. We always allocate a pool and do a contest. So yeah, briefly speaking, you have to do both. And there are obvious disadvantages of the contests where you have like 300 people and only 2 of them are actually doing the audit. And maybe they're not that good. So you never know. So we have to have a guaranteed audit by a set of professional auditors and also a crowdsourcing contest.
Okay, I'm going to say some things. So firstly, on my LinkedIn, if you find it, you can see a blog post where I described this problem like 5 years ago. So this is a problem of double-sided markets. So the problem with the double-sided market is like as an auditor, nobody has an ability to give an assurance about the quality of an audit. And similarly, on the other side of the problem, it's like given a smart contract, nobody really knows the real risk that one is underwriting. So the challenge we have is like, if you have just a normal auditor doing an audit, you get an answer, right? But again, this goes back to the problem. You, on a scale which is a variable, you can have incredibly good, which it's a tail distribution, you have very few people, so it's very unlikely that all the smart contracts are going to be audited by these people, right? So you need to have this matching problem. So it's essentially, do you have the people, the right skill, for the right level of risk that's being underwritten by a smart contract? So there are mechanisms to do this, and he's kind of alluding to one of them. I would say, you should borrow techniques from mechanism design, and this is a double-sided market, and fix it.
That seems fair. So towards my last question, what was your favorite smart contract or like hack in general in crypto, probably like this year or last year? And why do you think it was good enough to be appreciated? I mean, obviously people lost money, so it's bad, but in general.
My favorite hack is in the code which we audited, and it was also audited by 10 other companies, tier 1 security audit firms, and it was insanely good hack. We have a post-mortem in our blog. It's so good. I have such a huge respect to this bad guy who did this. He's extremely high skilled. It's insane. It was actually audited. There was a full-scale audit done by 10 tier 1 security firms, and all of them missed them. And then for 2 years, the bug existed in the production code with millions of dollars, and no one noticed it. And now it got hacked. So it happens.
Was it 1 inch or?
Yeah.
Okay.
It's 1 inch. So it was genuinely good hack, and yeah, that's my favorite one. Read our blog post about it.
Oh, nice.
I don't do a living auditing code, so I can't give one. Like, I don't want to be in one side of an argument. I have lots of ones where I look at it and go, look, this is really stupid. The way I would say it is like, if you can look at the code and it's obvious to you that it's going to happen, that's a low-hanging hack. When it's a hack in the mechanism design, that's when I would go. Like, if there is a hack, let's put it this way. If there is a hack, the person has created a bunch of circuits, connected it through some, what do we call, sophisticated cryptographic mechanisms, and then get the thing out from a mechanism design perspective, that's my hat off to that person. Let's put it that way.
Awesome. Let's put the floor to the audience if you guys have any questions. Looks like not. So I think then we're gonna wrap up. So yeah, thank you guys for doing this, and it was lovely. Thank you.